Okay, so today we're going to understand the slope of a line. Alright, so the slope of the line, you will hear people sometimes refer to slope as, and I'm going to talk about this letter here in just a second, as the rise over the run. Okay, so how far you go up and down over how far you go left or right. Now the letter M, there's a lot of things on the internet about why we use the letter M. None of it is conclusive as to why it's the most widely used letter for the slope, but it is. And so anytime you're looking at a formula or something like that and it has the letter M in it, it likely means slope. Alright, so now we're going to look at this GEOBOARD here. A GEOBOARD is just a board that has a bunch of pegs in it that are evenly spaced apart. And we're going to find out what the slope of this is. And remember, our slope is rise over run. Okay? So what I usually do is I go to my lowest point, and so I'm looking at from here to here. But I can't count diagonally. I have to move up and down and or left or right, okay? So from this bottom dot, I'm going to go up 1, 2, 3. So that's 3 on top. And then I'm going to move to the right 1, 2, 3, 4. So my bottom number is 4. So this line right here has a slope of 3/4. Okay, so what I want you to realize here is that if you move up or right, you are going in a positive direction. If you go down or left, you are going in a negative direction. Okay, so we're going to redo this slope, only this time we're going to start up here at the top point, this one. And whenever you go down, in order to get to that last dot, that last peg where that rubber band is, we're going to go down 1, 2, 3. So since I went down, that's negative. And now I'm going to move to the left 1, 2, 3, 4. And left is negative as well. And remember, positive 3 over positive 4 is the same thing as negative 3 over negative 4, because what is a negative divided by a negative? It's a positive. So these both equal 3/4. Alright, so let's look at this one. So again, I usually start at my lowest point. I just colored it in red, and I have to go up 1, so my slope is up 1. Now I have to go to the left, so left is negative. 1, 2, 3. Now, let's say that I started at my top point. So if I start here, I have to go down 1, so that's negative because it's down, and then I go to the right 1, 2, 3. So these slopes are the exact same. And I want you to keep in mind too, you could also write a negative slope just like that. The negative sign could just be off to the left. Okay, so this page is just letting you know we read our lines from left to right, from the left side to the right side, and if the line is going upwards, you have a positive slope. So from the left side to the right side, if you see that the line is going downwards, you have a negative slope. Okay, so on this one, we are going to use this GeoBoard to model a line with a slope of 1/2, and you could use graph paper if you wanted to. So that means you get to pick a point on this GeoBoard. It doesn't matter where it is. I'm just going to pick this one right here. And I'm going to model a slope of 1/2. That means from this red dot, I'm going to go up 1 and to the right 2 and put another dot. And then you connect your dots. That line right there has a slope of 1/2. Alright, so for this one, we're going to model a negative 1/4 slope. So that means I could model that, or I could model that. So I'm going to put a dot, just, let's see here, I'll put it right here. Now I want to go, let's see here, down 1, this means down, down 1, right 1, 2, 3, oh, I needed to scoot over a little bit more. I'm falling off my GeoBoard. Okay, so let's go right here to this one. Down 1, right 1, 2, 3, 4. So I've got a dot right there. Okay. Whenever they're further apart from each other, it's really hard to draw the line. Okay, so if I wanted to count it going the other way, so if I started here, I would go up 1, left 1, 2, 3, 4. So I still have a slope of -1/4. Alright, so this page right here is just kind of letting you know what we're doing whenever we're finding the slope. And you're already doing this anyway, but sometimes it just helps to have it in writing where you can actually read it. So why don't you hit pause and read through this and maybe take some notes if you need to. And I'll get back to you in just a second. Alright, so now we're actually finding the slope of a line that's on a graph. And this is a lot like finding the slope of a line that's on a geoboard. So the thing is, you have to pick 2 points that have integer coefficients. So that means whole number coefficients. So that means I wouldn't pick this dot right here because it doesn't lie exactly on a whole number where it has whole number coordinates. So I would probably pick this one right here. And it doesn't look like there are any other whole number coordinates until right there. So now I'm going to count from my bottom one up 1, 2, 3, 4, up 4, and then to the right 1, 2, 3, 4, 5, to the right 5. So this line has a slope of 4/5. Alright, so let's look at this one. So remember, this one's going downwards to the right, so we know that we're going to have a negative slope. And we've got to pick 2 good points. There's a good one, and there's a good one down here. So again, I always pick my lowest point, and I start from there, so I have to go up 1, 2, 3, up 3, and then to the left 1, 2, 3, 4, 5. So that's a -5. So if I start at my upper one, I would go down 1, 2, 3, so that would be a -3, and then to the right 5. So those are the same slope. Alright, this one, we can't pick the y-intercept this time because look how it's slightly below 2. So it looks like this is a good dot right here, and this is a good dot right here. So you want to go up 1, 2, 3, up 3, to the right 1, 2, 3, 4, 5. So this one has a slope of 3/5. Or if you started at your top one, down 3, 1, 2, 3, 4, 5. But honestly, you would never tell me that the slope is -3 over -5. You always need to reduce your fractions when you can, and a negative over a negative always needs to be written as a positive slope. Alright, so whenever you're finding the slope of a horizontal and a vertical line, I've got a picture that I will draw for you. Okay, and this is terrible, I know, sorry, but this is a little car, and this little car only drives to the right, okay? And so we have this horizontal line right here, and all horizontal lines, think of your car just sitting there. It's not moving, it's not giving it the gas, it's not giving it the brake, it's just sitting there. So all horizontal lines have a slope of 0, every one of them. And if you think of horizontal lines, think of the floor. You want your floor of your house to have a slope of 0. Otherwise, it's a little uncomfortable to walk on. Now, if the little car goes up the hill, then that's a positive slope. If the little car goes down the hill, that's a negative slope. The little car falls off this vertical line, which also could be seen as a cliff, And now the little car is undefined. All vertical lines have the same slope, and that slope is undefined. This page is just reiterating what I just told you. The slope of a horizontal line is 0. Take a look at this horizontal line. So its slope is 0. Now, whenever we were graphing this the other day, its equation is different. So the equation of this line is, and keep in mind it only crosses the y-axis, so it can only have a y in the equation, and it's wherever it crosses the y-axis at, and it crosses at 4. So the equation of the line is y equals 4. The slope is 0. So notice that the equation is different than the slope. All horizontal lines have a slope of 0, every one of them. Alright, and this is reminding you that the slope of a vertical line is undefined. Think about your car falling off the cliff. That car is now undefined. Alright, this vertical line has an equation of x equals 3. It can only have an x in the equation because it only crosses the x-axis. The slope of this line, though, is undefined. Okay, so on this page, I'm not even going to draw these. If you have only an x in the equation, you must have a vertical line, and so the slope of that is undefined. If you have just a y in the equation, you must have a horizontal line, so our slope is 0. And you don't have to write out the word 0. You can use the numeral if you want. Alright, so the slope of a line does have a formula that goes with it. And this is your formula right here. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Sometimes you will see this written in a math class as delta y over delta x. Delta stands for change. So you're changing your y's over your change in your x's. Keep in mind these subscripts are names. That does not mean you multiply anything by 2 or 1. They are names. So what this really means, the numerator means the y-coordinate of your second point minus the y-coordinate of your first point. All that is over the x-coordinate of your second point minus the x-coordinate of your first point. Okay, so now we're going to use that formula and we're going to plug in these values, and I'm going to call this x sub 1, y sub 1, and this is x sub 2, y sub 2. And here's what I'm going to recommend to you. This problem, it's not that big of a deal, but on problems where you have negative numbers, if you don't do this, then you might forget a negative sign somewhere. So I recommend that you do parenthesis minus parenthesis over parenthesis minus parenthesis, and then you fill in your parentheses. So in the upper left position is our y sub 2 position, which in this case is 5. In the upper right position is our y sub 1 position, and that is 2. Lower left is our x sub 2, which is 4, and lower right is our x sub 1, which is 1. Now just do the math. 5 minus 2 is 3, 4 minus 1 is 3, and this answer, although a great answer, you always need to reduce. So you would tell me that the slope is 1. Always reduce your fractions. Okay, now I'm going to do this problem again, but this time I'm going to let the first point be x sub 2, y sub 2, and x sub 1, y sub 1 is our second point. So we're going to do this formula again. And I'm going to show you that the order of those doesn't really matter, okay? So now upper left is our y sub 2, which is now 2. Upper right is our y sub 1, which is 5. Lower left is our x sub 2, which is 1. And lower right is our x sub 1, which is 4. Now just do the math. 2 minus 5 is negative 3. 1 minus 4 is negative 3. And that is also 1. Alright, so this problem right here is one of the problems that I was talking about. Whenever you have negative signs, people tend to lose their negatives if they don't do the parenthesis thing. So I'm going to let this be x sub 1 y sub 1 and x sub 2 y sub 2. Upper left is our y sub 2, so that's a 4. Upper right is our y sub 1, so that's negative 3. Lower left is our x sub 2, and lower right is our x sub 1. Now I'm going to do that math. I've got a double negative there and there, and there and there. So now we're going to go ahead and do the math. 4 plus 3 is 7. Negative 7 plus 2 is negative 5. So our slope is negative 7/5. Okay, on this problem we're going to graph the line passing through the point 1, negative 1, whose slope is m equals 3/4. So the first thing I want to do is I want to plot that point right there. 1, negative 1, that means right 1, down 1. So I'm going to go right there and put a dot. From that dot, I'm going to go up 3, right 4. 1, 2, 3, 1, 2, 3, 4. There we go. Now, keep in mind that 3 over 4 is the same thing as negative 3 over negative 4. So from that dot, I could have gone down 3, 1, 2, 3, left 1, 2, 3, 4. And then connect your dots. And you're done. Alright, on this problem, graph the line with the y-intercept of 2. So y-intercept of 2, remember, oops, that's silly. There we go, that's better. Okay, so I want to go to 2 on my y-axis. From there, I want to do my slope. So that's negative 2 over 3, or it's 2 over negative 3, as long as you only have one negative sign. So if it's negative 2 over 3, that means down 2, right 3, put a dot, or I could go up 2, left 3. And then connect your dots. And you're done. Alright, on this problem, we're going to graph the line passing through the point negative 1, negative 3, whose slope is m equals 4. Now don't forget, m equals 4 means 4 over 1. A lot of people forget that. Or it could be negative 4 over negative 1, and that's okay too. But the first thing you want to do is you want to plot that point. So that's left 1, down 3. From there, I want to go up 4, right 1. I can't really go down 4, left 1 because I'd fall off the graph, but I can keep going up 4, right 1 if I want. One more time, that's it. Alright, that's it. This one's done too. Okay, so the pitch of a roof is just a fancy word for the word slope, okay? But for roofs, they call it pitch. And so it says, knowing the pitch is important in climates where there's heavy snowfall. If the roof is too flat, the weight of the snow may cause it to collapse. What is the slope of the roof shown? And by the way, there are building codes that tell them what the pitch of the roof has to be. I don't know those codes, but I do know that they're out there. Okay, so don't forget you've got rise over run. So our rise is 9 feet. Our run is 18 feet. And this would be 1/2 once you reduce. So our pitch is 1/2. Alright, so I'm sure this is something that you all think about all the time, about your sewage pipes. And there are codes for that as well. Again, I don't know them, but it says they must slope down 1/4 inch per foot in order to drain properly. But in order to find the slope, you have to be comparing things in the same unit of measure. So instead of 1 foot, I'm going to put 12 inches here. Okay? And again, we want our rise, which is -1/4, over our run, in this case, which is 12. So I'm going to do the math here. -1/4 divided by 12 over 1. Remember, whenever you divide fractions, keep the first one, change the sign, flip your second one. So -1/4 times 1/12, and then you multiply straight across. Oops. So our slope is -1/48. Alright, so that's it for this lesson. If you have any questions, send me a message.